Sometimes you just need to know what a graph looks like for a parent function. So this video is about how to quickly reconstruct some parent graphs. So tangent and cotangent are a bunch of kind of S shapes. In order to reconstruct the details, you should think about where are their asymptotes, where are their zeros, and where is y positive and negative. So if tangent is sine over cosine, you can reconstruct the vertical asymptotes by thinking about where is cosine equal to 0. Because when you have the 0 in the denominator and a non-zero value in the numerator, you'll have an asymptote. So where is cosine equal to 0? Thinking on the unit circle, you would have at pi over 2, and 3 pi over 2, and 5 pi over 2, and 7 pi over 2, and so on. So you can really rapidly graph some asymptotes like this. Okay, where are the zeros? So you'll have zeros whenever y is equal to 0, and y is going to be 0 when the numerator is 0 and the denominator isn't. So when is the numerator equal to 0? So sine is equal to 0 at 0 and pi and 2 pi and 3 pi and so on. So if this is pi over 2 and that's pi, this is 3 pi over 2, that's 2 pi and so on. So the zeros are here exactly halfway in between the asymptotes. Okay, last part, we just have to figure out what the S shapes look like. So where is the y value positive? So I know that this entire thing will be positive when sine and cosine are both positive, or when sine and cosine are both negative. So sine and cosine are both positive in this region, and sine and cosine are both negative in this region. So that's an angle between 0 and pi over 2. So in terms of a graph, if sine and cosine are both positive, that means tangent is positive. So I know my graph has to be going up towards the asymptote, because the only other choice is for it to go down towards the asymptote, but that would give me negative y values. Okay, what about between negative pi over 2 and 0? That would be angles in this region. And here, cosine is positive, but sine is negative. So that would mean that a negative value divided by a positive value is negative. And so that tells me it looks like this. And because the whole thing is periodic, now you can just fill in the rest of it because you know that the shape repeats itself. So that's very rapidly how you can reconstruct tangent. Let's do that same thing for cotangent. So first think, where are the asymptotes going to be? Same place when sine equals 0. So that's going to be at multiples of pi. 0, pi, 2 pi, 3 pi, and so on. So let's make that pi, 2 pi, 0 was one of them, and so on. Okay, we know that the zeros of the function are when cosine equals 0 and sine doesn't. So that's going to be at pi over 2 plus whole integer multiples of pi. And so that happens exactly halfway between each of the asymptotes. Okay, so far so good. So now let's think about positive and negative. What about the interval between 0 and pi over 2? So in this interval. Again, we know that sine and cosine are both positive, which means that cotangent needs to be positive in this interval. So that means that the y values have to be going up towards the asymptote, because the only other option is to go down towards the asymptote, but that would make outputs that are negative. And we know that in this interval, you've got a positive divided by a positive, so they have to be positive. So that's what forces the S shapes in this direction, and then everything else is the same because it's a periodic function. Okay, the quick way to sketch secant and cosecant is to start by drawing either the sine or cosine function that they're based on. So let's do secant, which is 1 over cosine. I'll start by sketching the cosine function. So you do actually have to know what these look like. So this is pi over 2. This is 3 pi over 2. This is 0. So again, the first step is thinking about where are the asymptotes. You get an asymptote whenever cosine is equal to 0, and we see those on the graph here. So I'm just going to go ahead and draw asymptotes at those locations. Okay, what's happening between the asymptotes? When cosine equals 1, I know that secant also equals 1, because 1 divided by 1 is 1. So I know that secant is going to come together with the cosine function at each of these maximum and minimum values. Okay, so what is the secant function doing when the input value is like a little bit above 0 or a little bit below 0? Let's think about what happens to cosine. Cosine is going down towards 0. What happens when you divide 1 by a number smaller than 1? So like what happens when you divide 1 by 1/2, for example? What you end up getting is 2. What happens when you divide 1 by 1/10? You end up getting 10. So as the cosine values approach 0, 1 divided by the cosine values are approaching infinity. And that's what's sending you up to your asymptotes. So that's what's giving you the upward U shape, and you get downwards U shapes for the other ones. So long story short, sketch cosine. You know that you get asymptotes wherever the cosine crosses 0. And then you have these kind of U shapes which meet up with the cosine curve at the maximum and minimum values. Exact same story for sine and cosecant. So cosecant is the reciprocal of sine. So start by sketching the sine graph, and then you can go ahead and make vertical asymptotes wherever sine is 0, because that makes the denominator 0. And then your cosecant curve is going to meet up with sine at its maximums and minimums for the same reason as the other curve. And then you're going to create U shapes for the same reason as the other curve. So it's all kind of the same. So the goal here is for you to be able to rapidly reconstruct the shapes of these basic parent graphs, but also to have some inkling of the reason why. I hope this